Hello everybody, welcome back to another video with Mr. Coder, and in this video I'm going to be showing you how to do Bessie's birthday cake easy version. And this is from CodeTON Round 8, Division 1, Division 2, and this is problem C1. So basically Bessie has received a birthday cake from Elsie and it came as a regular polygon with n sides. And that means there's n vertices and they're labeled 1 through n clockwise. You and Bessie are going to choose some of the vertices to cut non-intersecting diagonals into the cake. In other words, the endpoints of the diagonals must be the part of the chosen vertices. Bessie would only like to give out pieces of cake which result in a triangle to keep consistently. Size of the pieces don't matter, and the whole cake does not have to be separated into all triangles. And then and there's also Bessie's chosen X of the vertices that can be used to form diagonals. She wants you to choose no more than Y other vertices. But for the easy version, Y is always going to be equal to 0. And what is the maximum number of triangular pieces that Bessie can give out? So basically, for this case, note that's always a regular polygon. So for the first case, so it's an octagon, x equals 4, and the different points will be 1, 2, 3, 4, 5, 6. And these are the points that you can use to make the that you can use for your diagonals. And then then if you try making as many triangles as possible, you'll realize that you can make 2, which is how they get the 2. And you can't just say you can't just say uh uh connect this, because the issue with this is that this point is not like given as a possible point that you can use, and nor is this, so you can't do like this or something. So that's why you can only have 1 and 2. So that's basically how you get the 2. And then if you have all the points, like here, if you have all the points in the octagon, then you can make the maximum number of triangles, which will be n minus 2, which is also 6. And then for this one, this is just a square, 1, 3, so then you can connect them, and it'll be 1, 2. And this is basically a demonstration. And one thing to note is that the triangle doesn't always have to have a side as one of the sides of the polygon. For example, if you look at this test case 2, they're given this 4 does not have any sides that's actually on the sides of the regular polygon. So that's something that you should know. Then basically how you do this problem will be just so you get the input in, and you basically start off with the number of vertices, because something to note is that, for example, back at this octagon, the first test case, and then this 1, 3, or 1, 2, 5, 6. Then if you notice that this point, like since you have 2 adjacent ones, that means that you can never form a triangle with these. And these ones, you can never, so then you can pretty much just subtract those from the number of vertices total that you'd use, which means that, so you can just cut it off pretty much. Now there's 1, 2, 3, 4. And that means that 4 would work. And then if we just say we had something like, I mean, if we had 1 here, 1 here, 1 here, and 1 here, like, because these aren't two connected with each other, two or more connected. So that's why it's always going to be possible. So then you can just have the the number of vertices total that aren't like the connected minus 2. So that's basically where the idea comes from. So basically what I did, I sorted all of them. I sorted all the points that you had. And then I also added to the end the n plus the first one. So then you can get the original back to the cycle. And then I go through each point, and then I check if the one greater than it minus the current one, if it's greater than or equal to 3. So for example, like if you had 1 blank blank 4, then it would be 2 gaps. So 4 minus 1 is equal to 3, and this has a 2 gap, which means that it would have to be greater than or equal to 3 for you to actually want to remove those points. So you just keep doing that, and then at the end, when you have the total number of vertices, you just do the number of vertices left and then minus 2 to get the number of triangles. This can be proven to work because it's always going to be a regular polygon. So then if we test this example and run it, and it gives 262. So thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next video. Bye.